Assalamualaikum warahmatullahi wabarakatuh, and a very good morning IB to Dr. Suraya binti Muhammad Tahir and my fellow friends. So my name is Muhammad Hadi bin Aziz and my metric number is 198934. So I will be presenting about the aluminium gearbox for powder metallurgy EMM4715. Okay, so here is the table content for today's presentation, which is introduction, advantage and disadvantage of using powder metallurgy process over the currently used manufacturing method, and summary. Okay, so for the introduction, so the gearbox is actually equipped with transmission gear, an important part of the automotive transmission system. So the gearbox shell's interior quality must be high in terms of strength, tightness, and lightness. Okay, so the aluminum gearbox is an actually excellent example of a component that is currently not manufactured using the powder metallurgy approach. Thus, I'm choosing this application. Okay, so for powder material selection and production, okay, atomization is a powder making technique, and mixers are used to combine powder and additive. Prior to mixing, lubricant are applied to make the compact easier to eject and reduce tool wear. And atomization is the process of breaking molten metal into very small particles, which then turn to small particles using high pressure fluid jets. Okay, so the impingement of high pressure gas or water breaks the liquid stream into droplets. So actually it has 5 stages, which is first one is small disruption cause the liquid surface to become wavy with fragmentation and the development of ligaments disintegration into tiny droplets. The pieces are further broken down into fine particles and particle collision and coalescence. So here is the diagram that show the atomization. Okay, so for compaction method, okay, so dies with tight tolerance are used to compact the material. Die-tool steel, cemented carbide, and hydraulic or mechanical presses are used to press the dies. Okay, so the primary goal of conversion is actually to create a green compact that is strong enough to survive the subsequent handling operation. Okay, after that, the green compact is taken to be sinterized. To strengthen the compact green strength, additives are added. Okay, so for slip casting, it has advantages of being able to make things that would be impossible to make by pressing and requiring more expensive equipment, and also working best with small powder particles. However, the procedure is slow and the commercial applications are restricted. Okay, so for the design and mode and tools, okay, so here is the product structure that is complicated with concave and convex structure covering the surface. Okay. Okay, next for sintering and other processes. Okay, so aluminum powder metallurgy is actually sintered under control condition in vacuum, and sintering temperature vary according to alloy composition, although they actually typically range between 595 degrees C and 625 degrees C. So the sintering time also range from 10 to 30 minutes. Okay, so for secondary operation, it includes crushing, grinding, and plating to provide fine dimensional, a good surface polish, increased density, and corrosion resistant. Machining procedure are selected to generate specified shapes and size, in which case very sharp tooling with slight rate is used, and EDM and laser cutting are also used to achieve a precise shape and size. Okay, next. Okay, so for the advantage and disadvantage of using powder metallurgy process over currently used manufacturing method for aluminum gearbox. Okay, so die casting is actually the current manufacturing method for aluminum gearbox. So compared to the powder metallurgy process, there are some advantages and disadvantages that can be discussed. Okay, so the first one is quality, of course. Okay, so a turbulent liquid fills the space in die casting and can sometimes trap air, resulting in non-filled, which is like material does not completely fill the mold, and internal flaws like as flow lines and porosity are frequent when oxide skin falls into liquid. And the advantage of this process is actually the uniformity of powder metallurgy. Okay, so next one is material implication. Okay, so die casting frequently employs non-ferrous material, which certain metals have low melting points. Okay, so powder metallurgy allows for far higher material and alloy diversity. So this permits the development of novel features such as high melting point, metal powders, and strong magnetic performance for an electric motor component. Okay, the last one is cost. So the cost of die casting and powder metallurgy also differ significantly. And powder metallurgy actually minimize scrap rates in terms of material use or yields, which is especially essential when working with high value materials like copper and stainless steel. Okay, so trimming die cast parts to remove flash, as well as some machining operation and maybe heat treatment are also always required for secondary processing. And most powder metals parts require little to no additional processing. Thank you.